Yeah, good morning, friends. Today we'll discuss remaining unit number 5 topics. Okay, so let's first we'll discuss compare between three communication modules. One is called as USART, USCI, USI. USART means Universal Serial Asynchronous Receiver or Transmitter. USCI means Universal Serial Communication Interface. USI means Universal Serial Interface. Comparing these three modules means what are the communication modules will be support in these modules. Let's come to the USART. This USART consists of UART. That consists only one UART module is available. Come to the USCI. In this, two UART is available. Already you know UART means Universal Asynchronous Receiver Transmitter. So USCI consists two UART modules are available, which are with the timing of divided by 16 clock frequency, and it has a automatic baud rate. Already we are discussed what is the baud rate. Number of characters per second is called as a baud rate. So in USCI consists automatic baud rate detection, and also it consists of infrared data association or accessing. Infrared data accessing encoder decoder is also available. In addition to that, it consists of two USCI modules. One is called as USCIA and another is called as USCIB. Whereas come to the USA, in USA we don't have UART. We don't have UART. So that is a comparison between USART, USCI, USI regarding UART. So in USART, only one module of UART. In USCI consists of two UARTs. In USI doesn't consist UART. Come to the USCRT. It consists of one SPI module is available. It operated as master and slave mode, and it consists of three or four wires mode. And SPI in USCI consists of two SPI modules are available. This is also operating with master and slave modes. It also consists 3 to 4 wire modes. And whereas in USA it consists of only one SPI available, which is also operating master and slave operation. Come to the USART. In USART consists of one I square C with master and slave relations up to 400 kilobytes per seconds data will be transmitted. And similarly in USCI consists one I square C, which is also called a simplified interrupt usage, and it is also master slave operation. Up to 400 kilobytes per second data will be transmitted. And in USA it I square C need a software state mission state mission algorithm is required for in USCI, and this is also operated US master and slave mode. So that is a comparison between USCRT, USCI, USI. Come to the briefly, USCRT consists of one UART, one SPI, one I square C. But whereas come to the USCI, two UARTs, two SPIs, one I square C. Come to the USI, we don't have UAT, one SPI, and one I squared C. So this is a simply you can learn. Okay, so that is a comparison. Next, come to the SPI using USI. SPI means serial peripheral interface using universal serial interface. Okay, in this we consists of three pins. We consists of mainly three pins. That those are called as USI pin enable sixth pin, pin enable seventh pin, pin enable fifth pin. These pins are used for serial data out, serial data in, and serial clock. Okay, so these are the use of these three pins. Okay, and these three pins will be another pin which is called as a fourth pin which is called as a SS will not be shown here. So total the fourth pin SPI are using USI. Okay, so here we are SPI consists of a shift register and a delatch is available. How this will be working? So let this shift register will be shifting by applying the clock. So how the clock will be generated? This clock is generated by using different clocks. So what are the clock? S clock and serial clock and A clock, SM clock, USI. USI means Universal Serial Interface. SW clock. SW means software clock. By using software, that means by using programming, you can generate the clock. And timer A0, timer A1, and timer A2. So by using these clocks, we can generate the any clock. This clock will be divided with the divided by 1, divided by 2, divided by 4, divided by 8, like that, divided by 128 for different frequencies. So once you are selecting different frequency, they are sending for selecting polarity. So either positive polarity or negative polarity will be selected by the USI MST. MST means a master. So because the clock is under control of master. So okay, so this master clock is synchronized with S clock, synchronized with the S clock because both are operating with the same frequency. So that's why that same frequency will be applied phase to selecting phase. These phase shifted phase shifted clock is applied to the shift register and as well as D latches. D latch means flip flap, D flip flap. So now you have to observe for the clock. So for shift register, the clock is a positive, and here D latch it is a bubble. Bubble indicates is a negative. So D latch will be work for negative edge triggering, and shift register will be work for a positive edge triggering of a clock signal, and the same clock signal is given to bit counter. That means this bit counter counts the number of bits. So that means how many bits we are going to transmit. That bits, that means shifting, those bits will be calculating by using bit counter. If bit counter reaches to maximum, at that time that interrupt will be generated. That interrupt is called USIFG, Universal Serial Interrupt Flag. Interrupt flag. So at that time that will be the clock will be stops. That means holds means stop the generation of clock, because SPI is mainly used in the synchronous mode. Synchronous means the clock is stopped, the transmission will be stopped. That's why the clock, once the bits are reached to maximum, then you have to stop the clock. That is the holds the clock frequency. Okay, so once whatever the shift register, the data bits will be shifted to D, and during the negative clock pulse, D will be sending to the out. That means that is a serial data out, and whatever the data we are received by using serial data in. Okay, so this is the SPI using USI, Universal Serial Interfacing. And similarly, go to the SPI using USCI. USCI means Universal Serial Communication Interface. It consists of it consists of two modules. So USCI USCI module, two modules are available. Now I'm going to explaining SPI using USCI because USCI is a asynchronous mode, but whereas USCI will be operated in synchronous mode. How that will be? We'll see the operation of SPI using USCI B module. Okay, so let's come to the here. So in this consists of only two clocks are available, only two clocks. Okay, so previously you have more clocks, but here only two clocks are available, and two separate shift registers and two separate buffers are available. One buffer will be used for transmit buffer, and another buffer will be used for receiver buffer. Okay, but whereas in previous case we have only one shift register, but here there are separate register. One will be used for transmit shift register, another will be used for receiver shift register. And similarly here we have a three pins. One pin is SS means slave selection is not shown, so this is also a 4-pin SPI. So let USCB, that means this is the B module, that's why I'm using UCB. O means 0x. So B not slave out, master in. That is a master in, slave out. Both are same. Slave out, master in, or master in, slave pin. And similarly here they can use for S clock or USC B naught clock. And similarly here serial slave in, master out, slave in. These are the three pins, and one pin is SS means slave selection pin is not shown. Okay, this is the 4-pin SPI using USCI module. USCI module. So once the clock is given, so at that time the transmit buffer receives an interrupt. That means the data is ready to transmit. So once the flag is generated, transmitting buffer is generated, transmitting uh, interrupt flag is generated, then this transmit buffer receives the data. That receives the data is sended into transmit shift register. This transmit shift register is sending the data, transmitting the data to the to the slave by using master out, slave in, slave in here, slave in. That means the slave will be receives the data. So the master is sending, the slave will be receiving. Similarly, at the slave, the slave is transmitting. At that time, the we are called as a master in, slave out. Okay, so master in, that means master will be receiving, and whatever the slave will be transmitting. So then this received data is placed in a receiver shift register. That will be this shift registers, both transmit and receive shift register, shifting the bits one by one for every one clock pulse. Okay, so for every one clock pulse, let us assume, if suppose if you have received 8 data bits, then these 8 data bits is sent to the receiver buffer. Once receiver buffer receives the all the data 8 bits, then we can generate the interrupt flag, that is a USCB not. RX means receiver, IFG means interrupt flag. Okay, so that indicates we are received the total 8 bits. So this is the SPI using USCI. Okay, then go to the next one. So let's come to the USCIA module. Already we are discussed. Previous one is a excuse me. Previous one is a synchronous mode, but now USCI is a asynchronous mode. SPI using USCI. SPI using USCI A module. A module is a asynchronous. Asynchronous means we need stop bits, parity bits, along with whatever the data you are going to transmit. Okay, so the remaining blocks are almost all same. Whatever the blocks we have studied in previous condition, previously same, but here this module will be operating in asynchronous mode. Please observe. So now here different clocks are available. What are that? You see not clock, that means universal serial interfacing module 0 clock, and A clock, SM clock. Okay, 3 clocks. Okay, same clock will be repeating, don't bother about that. Okay, so 3 clocks are mainly these 3 clocks are selected by using different baud rate clocks with the pre-scaling. That pre-scaling means divided by 1, divided by 2, divided by 3, or divided by 4 for different frequencies is called as a pre-scaler modular. Once we are selecting different frequencies, now you have to observe here we are using two different clocks. One clock for receiving, one clock will be used for transmission. So that's why we are not depending on clock frequency. So that's why in asynchronous mode we are measured the clocks in terms of baud rate. Okay, please understand. Baud rate means number of characters per second. What is the need of clock? Clock means for transmitting. How the data will be transmitted. So many students will get the doubts. Sir, previously we are told in asynchronous mode doesn't want clock. Yes. So clock means here for transmitting the data, we need the clock. But these frequencies are not an important. But whereas in synchronous mode, the frequency is very important. But here asynchronous, the frequency is not an important. That is the main concept. Okay, so then you have to observe here 4 bits are there for transmit shift register. That's why those are called UC 7 bit, because the data bits are 7 bits or 8 bits we are using. Generally 7 bits means ASCII code is a 7-bit code. ASCII code we are studied in DLD or STLD. You are studied. Okay, so that is ASCII code is a 7-bit code, and American Standard Code for Information Interchange Code is a 7-bit code. That is a ASCII code is using, or yeah, that is a EBCDI, that is a uh, extended code, extended BCD code is a 8-bit code. That is a 8-bit code. Okay, so that will be selected by using this one. 0 means that is a 8-bit will be selected. 1 means 7-bit will be selected. And similarly here the MSB bit. So you are transmitting first is a MSB bit or LSB bit, that will be selected by using MSB. And here PAR, that means parity. Parity either even or odd will be selected. Parity odd, AR means generally parity odd. Parity odd will be selected. Then parity enable, that means you are transmitting along with parity or not, so that will be used for parity enable. So I'll repeat, this will be used for parity enable. Here this will be used for even parity or odd parity. Here this will be used for either MSB or LSB. Here this bit is used for 8-bit or 7-bit. Okay, so here also, if once data how to transmit, first you have to place in TX means a transmitter buffer. Once you have to place in transmit buffer, then that data is placed in the transmit buffer. In the transmit buffer, for every one clock, 1 bit will be transmitted. Then come to the here RX pin. This RX pin receives the bit by bit again. Here the bits are 7 bits or 8 bits along with parity and start and stop bits will be received. So here the clock frequency is different compared to the transmitter. Okay, so here receiving the frequency is different. Okay, so once we are received the total bits, then the data bits are placed in the receiver buffer for the other for the other purposes. This is the asynchronous USCI module. Okay, next we go to the I squared C. I squared C means I2C means IIC means inter-integrated circuit. You can observe here we have a integrated means ICs. Different ICs are available. ICs means which consists of a transistors. So here we can use N MOSFETs or use N channel MOSFETs are used. How that will be? You have to see. Come to this. I square C is a two line, two wire. So these two wires are SDA and SCL. So that's why these two are two line protocol is a I square C. These two lines are operated with the VCC or VDD. Don't bother about that. VCC or VDD with the pull up resistors. With the pull up resistors. If suppose here SDA and SCL signals for the master and slaves. Okay, here I square C consists of more number of masters and more number of slaves. Okay, so the slaves are identified by using 7-bit address. Slaves are identified 7-bit address. Okay, so here more number of master and more number of slaves. The slaves are identified by using 7-bit address. So each slave has its own 7-bit address. So any master can access any slave, but only one master, one slave will be active at a time. Okay, that you have to observe. Only one master, one slave will be active at a time. Okay, so then this, if suppose SDA and SCL, if not available, the signals are not available at that time, this SDA and SCL both are connected to the VCC, connected to the VCC. That means those two are active high, active 1 position. If the signal is present, if the signals are present, then NMOS will be operated, that is on condition. If that is on condition, those will be act as a short circuit. Short circuit means this SDA and SCL connected pull down to the BSS. That means connected at logic 0. Okay, so that is a I square C. Then come to the here, smart electric meter or energy meter. Smart energy meter using Wi-Fi connection, which is called as a CC3100. Okay, that is a Wi-Fi module number, that is CC3100. So don't fear about this diagram, there is simple diagram. Okay, so here we have a three-phase mission, three-phase mission. So phase 1, phase 2, phase 3, or phase A, phase B, phase C, with the neutral, with the neutral which is connected to the ground. Okay, so that's why we have a three phase model mission is shown in the diagram. These three phase are connected with the 7 modulators, which is a sigma delta modulator. Sigma delta, which is called as analog to digital converter, because this three phase is a analog signal will be generated. That analog signal is converted into digital signals by using sigma delta analog to digital converters. Please observe, these are the 7 analog to digital converters. So top 3 will be used for, top 3 will be used for to measure the currents, and bottom 3 are will be used for to measure the voltages, and this center one will be used for common neutral. Okay, that's why this is a very simple diagram, and this feature is available in 6XX family, that is a 6th generation family, and this is connected to the internet. For the internet we are using Wi-Fi module, so that's why Wi-Fi is connected. That's why we are called as a smart electric meter. So this electric meter will be used for to measure all electrical parameters, that may be voltage, current, RMS values, powers, energies, every electric parameters will be measured by using these smart energy meter. Whatever the data is measured, parameters are measured, that will be transmitted to the any mobile phone or any smart devices by using a Wi-Fi module. The Wi-Fi module is called as a CC3100, which is available within the our 6th generation module, that is on chip is available. So within the single chip we have consists of in Wi-Fi module. Okay, that what is a Wi-Fi module we'll discuss later. Then this Wi-Fi module is connected our interface with our energy meter, or sorry, with the our microcontroller, sixth generation microcontroller with VCC, ground, and SPIs. Okay, that four clocks. Okay, four pin SPIs, four wire SPIs, master in, master out, clock, and master out, slave in, and chip selections. Okay, similarly, we have a interrupt request is available, interrupt request is available, and here we have a UART transmitter and as well as the receiver with the baud rate of 9600, already we are discussed, and a crystal frequency 3.32 kilohertz, 32 kilohertz crystal frequency is connected between X in and X out, and general purpose input and output. Okay, general purpose input and output which is connected, LEDs will be connected. So these are the main parts, which is here also we have connected a VCC and VSS with the reset modules are connected here also. Okay, so this is a simple smart electric energy meter. So simply whatever the modules are available, that thing you have to explain. Here you have to observe sigma delta a 24. This means 24-bit analog to digital converters are mainly used. This the future of this 6xx is, this feature is available only in sixth generation. That is a 6xx family only, and also it consists of 32-bit multiplier. That means if a energy we are measuring a very big values, more values, very large values, at that time also we can measure the by using 32-bit by 32-bit multiplier. Okay, same thing I am explained here also. Okay, so it perform all metrology functions, and it metrology function is all parameters, and it is controlled with the simple link which is called as a Wi-Fi trans receiver. So this module is available in only sixth generation, and sixth generation is unavailable in the system on chip. SoC means system on chip. Okay, then it is operated with 25 megahertz CPU. Okay, and it consists of 7 independent 24-bit sigma delta analog to digital converter with second order differential inputs, and also consists of 32-bit by 32-bit multiplier for measuring very big values. Okay, and also it consists of a software energy library, supports the calculation of various parameters. Okay, so then CC10 is also available within this chip, which consists of all protocols for Wi-Fi and internet, which is greatly minimizes host microcontroller unit software requirements, because this CC13100 consists of all the software which is required to interfacing to the any microcontroller. That's why it considers it requires less software to interfacing this Wi-Fi module. Okay, so that is a energy meter. So don't bother seeing the, after seeing your diagram, don't fear to let them practice. Okay, let them go to the next one. That is a CC3100. It is a very important 2 marks, either 2 marks or big question is a very important. Okay, so CC3100 is a internet, a Wi-Fi internet or internet protocol. Okay, so this is developed by a Texas Instruments, is a wireless network processor module which allows a Wi-Fi to a low power, low cost microcontrollers for internet applications, internet of things applications, IoT applications. Okay, this CC3100 is a first Wi-Fi certified chip used for wireless networking. This device is is simple to implement for internet connectivity, and this CC310 integrates means this 3100 IC consists of all the software regarding Wi-Fi and Internet of the Things. So that's why if you are interfacing to the microcontroller, it requires less software for microcontroller to accessing these features. And this CC3100 is more secure with robust and simple security experience. Additionally, it consists of more tools and software and sample applications and user and programming guides, reference designs for Texas and to and support communication. That means up to small application to big applications, everything is available in a CC3100. So let what are the modules are available. CC13100 consists of SPI flash, that means serial peripheral interfacing, a flash memory, and it is operating with the 40 megahertz crystal, which is connecting to the antenna for transmitting the data is a antenna. And here the interface with the microcontrollers. That microcontroller will be operating 32 kilohertz crystal oscillator. The same both will be connected with the power supply VCC, and microcontroller clock is connected to the 32 kilohertz, and that is a host interrupts are generated, and as well as SPI protocols and UART protocols also supports this CC3100 is a most powerful Wi-Fi module in Texas Instruments are mainly used. Okay, then come to the a small definition which is called as a bit banging. What is meant by bit banging? Bit banging means in the SPI, this bit banging is mainly used in SPI communication, serial peripheral interface communication. In this SPI communication, if hardware is not working properly, at that time you can transmit the data by using a software. So without hardware, if you are using software, SPI module is running, then we are called as a bit banging. We are called as a bit banging. So the bit banging is mainly used where a microcontroller with required interfacing is not available. That means hardware is not available, and also it is a more expensive. The cost is very high at that time. You can use a software for SPI communication. So that is called as a bit banking. Then next come to the another definition which is called as a CC3100 email demo application. So this demo, let them see the diagram. You will get a clear idea about this. Okay, so microcontroller is two Wi-Fi module, that is a CC3100. So we are transmitting from the microcontroller to a router to internet. So internet to a SMTP server. SMTP means this simple mail, what is that? Simple mail transfer protocol. Simple mail transfer protocol. So the simple mail transfer protocol receives the mails and similarly transmits the mails. That is a one box which is server which is used called as a SMTP. So whatever the mail you are written in our microcontroller, that microcontroller mail data is transmitted and placed in a SMTP server, and again this SMTP server again transmitting to the particular device or particular applicant user, particular user by using an internet, internet. Okay, this is a simple application of email application. Same thing I'm written here for the email demo application. Okay, go through and go to the next one. USB. Generally, more nowadays we are using, most of them are using USB. USB means Universal Serial Bus. Universal Serial Bus. USB means Universal Serial Bus. So our pen, you have to see that our pen drives is a in the model of USB pins, what we call as a USB slots. Okay, USB means Universal Serial Bus. It is also worked as a master and slave, and it consists of one master and more number of slaves are available. That means single host, single master, and more number of slaves, that is the devices are available. Up to 127 slaves are connected by using star delta, star connection, by using the star connection with the help of hub. These devices, that means slaves, are connected with the vendor and product ID. Vendor and product ID is used to identifying to the a particular slave or device. Okay, then this device will be look like a single address bus. Is look like a single address bus. That how that will be look like, see here. So that will be only one line, so that's why we are called as a single, look like a single address bus, but not like that, because every device have a its own unique vendor and product ID. Okay, it is a simple of the USB module. This USB module is a different versions are available. USB 1.0, 2.0 and 3.0 is running, I think. USB 3.0 is running, but in our application you have USB 2.0, which supports the control interrupts and bulk data transfer with the rate of 12 megabits per second. And USB is mainly used to remove or resume and remote wake up operations, and it can be configured. That means in our MSP 430 you have consists of 8 input and 8 output endpoints. Okay, then this module consists, integrate means on chip, a physical interface and as well as a phase lock loop for USB clock generator, because data of how to transmit clock is necessary. Okay, then it is flexible for power supply system for enabling bus powered and self powered devices. So we don't want an extra power, So what, whenever we have to connect the system, at that time that power will be received by the this USB. Then come to the another application which is called as a CAN. CAN means CAN means controller area network, which is the most powerful electromagnet, sorry, which is called as a electromechanical mechatronics, simply called as a mechatronics protocol. The mechatronics protocol is called as a CAN. CAN means controller area network. This CAN is mainly used in a automobile communications. So you have to interconnecting between the engine system, gear control, light control, airbags, air conditioning, central locking, and everything will be connected or controlled by using CAN protocol. The CAN protocol is introduced first in Robert Bush, okay, in 1983 for automobile industry system. So once you have to, this can is implemented, then this will be mainly first they are used for fuel efficient and safe, and after that this will be used for all automobile industry, and it will be more developments in electronics and communication devices or takes place. That's why the automobile structure day by day will be totally changes with the this CAN control area network. Okay, then come to the this is the your unit 5. Okay, so please practice it. Okay, thank you.